What you're not going to see tonight are the moans and the groans and the disappointments and the surrenders and the delays and the redesigns and the errors and the frustrations and the emotional explosions that are part of any meaningful project. What you will see, however, is the teamwork and triumphs of students who literally grew up on this great campus. I'm proud of them, I'm proud of what they've achieved, and I now will hand it over to Mrs. Rondon.
Hello. Dear students, parents, clients, industrial mentors, Mr. Lorry, Dr. Lorry, administrators and faculty member, we thank you. Because your dedication, support, help, commitment, and hard work have made these projects possible today. You have made all this learning possible. Please give a round of applause to the first graduating engineering class of 2012. Thank you. As you know, they are completing today their engineering track with Project Lead the Way, a rigorous 4-year program. Since they started the track, they have worked and helped design all kinds of innovative projects. Everything from a wheelchair for students with disabilities to a lawnmower blade sharpener, and contributed heavily with 4 different robots. During this academic year only, in the first semester, and together with the pre-med students, this group of students, they designed a defibrillator and the base of the current robot while doing the required internship at Motorola Mobility, and with the help of their designers and engineers. Simultaneously, all of them worked and presented science fair projects. They also work on all of their classes, and they developed the beginning of the projects that you will see today. During the second semester, many of the students worked on the robotics season. If you don't know what that is, it means 50 kids from 9th grade to 12th grade working very hard, and mentors like Massimo Salafia, they commit to design and build a robot in 6 weeks. That is quite a challenge and also a very intense experience. When they got the robot finished, we went to regional competition, and we went twice, and we made it to semifinals twice, and it was out of 60 and 40 teams, so yay for us! Meanwhile, they continued with all their classes. They went to college visits, they toured colleges out of town, they interviewed, they got accepted to college. They did internship at Hazen and Sawyer's Environmental Engineers. They went to internship to Bentley Systems. They went to Motorola Solutions as well. They were mentored by professionals from the field like Mr. Jesus Quills, which is sitting right here with us, Mr. Ed Suarez and Heath Camp, which all came and evaluated their work so we would be able to progress and improve our prototypes. And in their spare time, the students work in these projects that you are going to see today. So please, I hope you all enjoy the presentations as much as I enjoy working with them this year, and to see them grow and learn as much as I saw them grow this year. Please join them. They will present one team after the other, and after the 4 teams present, we will walk around and ask them questions and interact with them and have fun. Thank you. Good night.
Hi, my name's Chris, and our team is me, David, and Sebastian, and we're gonna start off with a little skit first before our presentation. So if you don't mind the silliness, we'll begin straight away.
Honey, can you do the laundry tonight? I done it last night. Please.
Normally, I wouldn't like to do this, but we bought a super cool all-in-one laundry machine station. I'll do it tonight. I'll make the exception.
As you can see, our cabinet has plenty of storage space for many bottles, like detergent bottles, irons, and anything you would include in your list of laundry paraphernalia. Now this is the first element that makes our product special. This is our hanging apparatus, and it has multiple height levels. You could have it maximum height, as Sebastian has it right now, medium height, or off. You can also tell from the crossbar that you could hang at least 15 hangers with shirts on them, and there's plenty of room between the bottom of the shirts and the top of the cabinet. Now this is the second element, our adapted flip fold. The flip fold, I don't know if you guys know from watching Big Bang Theory or commercials. It basically folds shirts in a set size and shape, and we added handles to it to sort of make it more comfortable and easy and enjoyable to flip the flaps and fold the shirt. We also added, as you can tell, some sound bites to make it fun for kids to. But yeah, the sound bites, and we also added visuals under the flaps is to cater to a younger population, make it more family friendly. So not only moms don't have to do all the work, their moms can train their kids to fold their shirts and pants when they're too busy. And this is the third element of our cabinet, the ironing board. You can tell that it's elevated on legs so you can slip the sleeves through to iron a specific part of the shirt. The ironing board is a smaller version, but it's still big enough to iron most pieces of clothing. And the special part about it is that you can take it out from the side where it's hidden and just as easily move it back and hide it again.
That wasn't so bad after all.
Honey, you gotta hurry up, we got company coming.
Now the final part about our all-in-one laundry station is that you could as quickly put everything on as well as take everything off. Minus that. In less than 1 minute, you can put away the ironing board and take down the hanging apparatus, and you're back where you started, and your guests will not know any better. Now we hope you enjoyed our little production. It was put together at the last minute, so apologize for anything weird. But this is our presentation in PowerPoint. We're gonna try to get more into depth in it. Alright, let's go. So this is it's called the all-in-one laundry station. We included the 3 main elements, but none of the ones that we researched had both or all of ironing, hanging, and folding. So that was the third problem that we tried to fix. From our research, you could see that those 3 are the leading brands of laundry organizers and laundry stations out there. They range from the basic ones, like the one on the top, just $40. The more expensive ones are about $100. And you can see they don't even do all of what our product can do. Then we also researched specifically products outside in the market that would ease the folding of clothes. We first found on YouTube a product from an Italian company called Giosi e Cavazuti. I don't know if I said that right, but it basically is a really expensive but very, very efficient automated t-shirt folder. But of course it's for industrial or for the industry, for companies and department stores, and totally not for domestic use. Then we did more research and we found the flip fold, which was considerably cheaper, and we really liked the basic concept, the simplicity and the aesthetic appeal behind it. So we decided, okay, let's incorporate it but also improve it. So we went and we added handles, little fiberglass sticks basically, but they work wonders because it's you could tell, and if you check us out at our booth after the presentation, it is a lot of fun. It's pretty addicting to flip it, as some people who've tried it can attest to. Alright, so here's the slightly boringer part, but just as necessary and often overlooked. It's the all-important 12-step design process, and we didn't want to like split it up into all 12 steps. So this is the first chunk of steps, and basically the first picture on the top left, the cheaper automatic shirt folder, is actually the thing that inspired us to do this entire project to begin with. It's on YouTube, it's made out of K'NEX, and it's automated, and it's really simple, but the idea is ingenious, and that's what got us started. Then the brainstorming process is exemplified by the top right and bottom left pictures, and they're just hand drawings. We first thought like, let's try to automate it with CIM motors, but that's expensive, and we didn't want to add all the bulk and the weight and complexity. So we thought about, okay, how about something more simple by using the power of rubber bands and physics, but that also didn't work out, and we ended up using just an improvement on the flip fold itself directly. And the bottom right picture, the laundry storage, the laundry station doubling as a storage is one of many things that we researched, many ideas that we researched, and led to offshoots of other ideas that we generated. To continue the design process, we thought of constraints and criteria that we had to meet. The most important to us was that it's capable of doing all three of the essential elements. So it has to be able to hang clothes. It has to be able you have to be able to iron clothes on an ironing board, and you have to be able to fold clothes on it, and it has to have storage space. That was also important to us. This product also seems to be one that people from college students to people living in small houses, crowded houses, can use and have everything in one spot. Because doing laundry is a very voluminous, space-consuming task. So we said, okay, let's have this on a 3-foot by 3-foot footprint, and we beat that by a little bit. And thirdly, we wanted the device, all the little contraptions and things, which made it a little unseemly, to be able to transform into an unassuming and normal-looking piece of furniture. So we selected our approach, and we went with the laundry station cabinet, and that's how our concept began. This series of pictures demonstrates the process, the manufacturing process, starting with cutting the wood from scratch and into the correct sizes, putting it together. After that, we went one by one through the elements and added. First, you can see assembling the hanger bar, the ironing board, putting them in the sleeves, which is what allows them to adjust their height, adding holes to allow them some levels. You could see in detail the handles that we added to the folder. They don't look like much, but they do feel really, really awesome. And on the bottom right, we ended up spray painting the cabinets and bars and just trying to make it look as professional as possible. We did show the ironing board. This was the most complex mechanism. We added 2 rails here that would allow it to go up and down. We added a hinge that would allow it to fold horizontally, and we added legs so that it could stand elevated. Okay, so we haven't actually tested yet, but if we did test it, we would first start off by testing the weight. The wheels that we had could support up to 400 pounds of pressure, and it definitely can support what we have on our cabinet. The hanger bar should support the weight of several hangers, and could show you that it did meet up to the task. The ironing board should remain sturdy while we iron, and it did. And all this you can see when you visit our booth. You can actually try it out yourself. And consumer feedback for ease of use, and that's just part of the regular design analysis procedures. Now, future steps we could take are to develop our sound and audio entertainment system better. You can see just the little piece of sound that you heard was from a greeting card that sings. Something like that we could develop and add visuals, add animation like a little LED screen, and basically make it into a fun experience for kids. That was just a conceptual design, but we could definitely take future steps to improve on that. Our hanger bar, or our entire hanger apparatus was made of PVC, since this is a prototype, but we definitely want to make it out of aluminum. Another future step that we'd be interested in taking is under the ironing board, there's room enough to put an iron. So you don't have to do what Sebastian did and bend down, open the door, and pick it up. You could just bend down and take it off a magnet, for example, or a gripped holder, a hook. And of course, we would always want less custom parts, since this is a prototype. We're gonna mass produce our parts to lower costs. And yeah, basically these are our products. Like it or love it or hate it, this is what it is. And we just love for you guys to come and check out our all-in-one laundry station, and we thank you for your interest and your time.
We're Team DMK for several reasons. I'm Diego.
I'm Michael.
I'm Kendrick.
All right, and let's start this off. So first, we'd like to talk to you about this project. Now, as the previous group demonstrated, and the two groups after us will demonstrate, we are working on a project that's been given to us as our 4th year in the engineering program. And this project was given to us by Ms. Rondon to basically go out, think of a problem in the world that we think needs to be solved. Think of a system or a process that could be made better, and then to find a solution to that problem. So to find the solution and to develop our solution, we have to go through the 12-step design process. This design process takes us from brainstorming and coming up with our actual problem to actually presenting the results, which we're doing for you guys tonight. And this design process, 12 steps, it's been drilled into our heads for the last 4 years. PLTW is very insistent that we know it. So yeah, as you can see in the picture, that's the 12 of us all beaming in our lovely engineering class. And we'll get started walking you through how we did this.
All right. First of all, we started with the problem for hiking. Hiking deals with a lot of stress and a lot of physically enduring capabilities. Hikers hike with heavy backpacks. 40 pounds is what you normally find in a backpack, and 10% of that goes to solely water. With that said, the hiker is limited by his or her capacity to store water. In order for a person to last longer in their expeditions, they need more water. With that said, more water needs more storage for their backpack, which is a heavier load, but unfortunately they're not able to have a balance between enough water to carry or enough load they have. We proposed an idea to have a water filtration unit that can store water and facilitate the need to filter the water if they're near by a water source, so that way they can constantly recycle water to help save on storage for them.
So what you're looking at here is our Gantt chart, and basically it's a schedule of everything that we planned out to do by the end of the project, which is today. You can see that it's highlighted May and presenting results. That means we are presenting the results here to you. Basically what the bars mean is how long we spent on each step of the design process. You can see that research took a lot of time, actually. probably a month. And this is because we wanted to make sure that we would design the best product possible using the information available through online research and even surveys that we did with hikers and Boy Scouts. You can see that also selecting an approach was a month-long process, and this is because we consulted experts to help us refine our design and actually make it better. And we spent a long time arguing and deliberating what we should include and what we shouldn't include, but in the end, we believe that it actually benefited us. You can also see that there's a gap between December and January, and that is winter break. We like our vacations.
Now, since we started our engineering course, we've been hardwired to always focus on the initial points of brainstorming. We always want to make sure our brainstorming serves a purpose, to make sure all our ideas have one and have a valid point that we can use in our future. We want to keep our brainstorming relevant to any product or any cause that we see fit. We always focus on consumer needs whenever developing a product, and we want to make sure that our broad brainstorming ideas are focused and channeled into what a product may be for a potential consumer.
All right, so after the brainstorming process, we started out very varied. We had a lot of different ideas bouncing around. But we all kind of came to the general consensus that we wanted to build some kind of backpack, a hiking apparatus, and we started to think of all the necessities that a hiker may need. So as you can see up on the screen, the first idea that we came up with is actually called the OmniPack. And so the OmniPack was an all-inclusive backpack. It had a weight distributing system so that it would take stress away from the shoulders and back, which are two of the main stress points for hikers because they're carrying a heavy load. It also had kinetic energy generating systems, either in the shoes or in the sleeves of the shirt. And what this would do is charge your various electronics, GPS, cell phones, etc., while you were moving, so you didn't have to carry weight in batteries, and you always had a dependable source of energy. And then finally, is the filter component. The filter component was a built-in filter for the backpack, which we already mentioned. And this filter would just allow you to cut down on the weight of water and just always have a clean water supply whenever you were hiking and for however long you were out in the wilderness. Now, the reason why our problem statement and what we've talked about so far doesn't reflect all three of these elements, just the filter, is because we presented this idea to a basically board of experts and mentors, some from Motorola, among other companies. And these mentors kind of evaluated our idea. There were some flaws here and there, which is natural, I mean, just kids. But we took their suggestions to heart, and basically what we did is we compromised. We said, let's set some of these features to the side, and let's focus on one and make it really, really good, instead of spreading ourselves across three and coming up with a so-so project. So now for the rest of the presentation, you'll see how we got from this OmniPack, focusing just on the filter, to what we actually have to present for you today.
So we decided to develop the water filter part of the OmniPack, and as you can see here, there are three pictures. To the left and right are the intermediary steps that we took in trying to actually make our product. In the middle is the final prototype, which isn't an actual it's a working prototype, which means it does the function, but it's not supposed to be to scale. It's just to represent what it should do. So as you can see, it's composed of two bags at the top, and these are to hold the dirty water that you find along a trail. You'll pour it in, and it'll hold the water in there while you're walking. So this water feeds into the filter and then feeds into these two other containers, which will hold the clean water. And basically what happens is, as you drink water from the lower two containers, more water will be filtered from the top. And this basically allows people that come across water to, instead of stop and pump the water or maybe wait and purify it, they can just pour it in the top and then just be on their way. At the bottom you can see a valve, and that is pretty much on and off to, if you want to provide flow to this hose. And up here we have a bite valve, so even if you have flow, if you're not actively drinking it, water will not spill out of the tubing.
Don't worry, we'll demonstrate it for you guys a little bit later.
So after we had a working prototype, we decided to focus on the aesthetic aspects of it. One huge product that you may see on the market that helped inspired us and we plan on innovating it was the Camelback. Now the Camelback, for those of you who do not know what it is a small hydration unit that resembles a backpack and only stores water, roughly 1.5 to 2 liters depending on the size of the unit. Since no one has ever really focused on the filtration part of it, we decided to blend Camelback aspects with our proposed filter idea that can hold just as much as a Camelback, but can also filter dirty water into clean water and also have compartmentalization to hold other products that you may take on with a hike. As you may see here in some of our sketches, our product serves as a regular backpack, or it can be mounted onto a hiking backpack to help facilitate for space. We focused on sleek packaging for the backpack, where it's not really bulky and you have a nice modular filtration unit where the bag itself can actually mold into your back or mold along with the hiking bag so it doesn't really slosh around. And we focused on certain pockets that might be convenient for the user when they're just taking the filter unit themselves.
All right, so after the sketching step, we have our working prototype, so we know what the job is that we need to get done. We have the sketches, so we kind of know what we want it to look like. So the next step for us is computer-aided design. So these models that you see on the bottom left-hand side of the screen are models that we created in Autodesk, which is a computer-aided design program that we use here. And basically what it does is it lets us design what we envision to be the final product in the computer. And so, as you can see, I don't know, it's kind of hard to see, but there are these dividers here. So those dividers are located in the top and the bottom sections of the filter, and what those do is they prevent water from sloshing back and forth. So even when the hiker is moving quickly, that water doesn't disrupt their balance. And then the filter is at an angle to conserve on space, and the space that's lost on those two corners will be taken up by pockets and things like that. Now on the top right, we have some of our final concept sketches that show what we want the final product to actually look like. The top right is the closest to what would actually be on the shelves. So it's got a sleek design. It's called the Koala Pack for a couple different reasons, one of which is that it kind of clings to the bigger backpack, like a koala does. Then that top right image is supposed to evoke the thought of arms and legs on the top and bottom. And then, as any good koala or marsupial, it's got many pockets so you can store things like that. The bottom one shows the two mechanisms at the top that allow it to connect to the larger backpack. These are just simply Velcro strips that stick off the top of the bag, loop around the top of the backpack straps, or some hiking backpacks have external frames. And so that allows the backpack to clip on, hang off, and let gravity do the rest of the work for the filtration. And then the top left actually shows a representation of the backpack hanging off, clipped in, secure, so that it's good for your hiking.
We ran into time constraints and resource constraints doing this project. We were limited to 1 year, so we couldn't pursue it past the prototyping stage. But we're hoping that future classes will be able to pick this up because it is an offshoot of the OmniPack, which did include kinetic energy harvesting and also weight distribution. So we're hoping that maybe future classes can pick up on that and actually combine with our product to make the complete backpack, utility backpack. They'll also have better equipment available. We used a 3D printer to actually make a model.
And acknowledgements to many of the people who helped us out during this project. We on Team STC would like to thank Mrs. Rondon for her tolerance and support throughout the process. Our fellow classmates for all their help and suggestions, experts and mentors for their feedback, and of course to Mr. Salafia for his invaluable guidance and expertise. All right, up top, and then we're just gonna slowly pour the water in. And just for reference, just as a taste test, let me just up, keep. only a couple viruses. It's really okay.
The depth, the width, and the height of the actual filter, you can see that it is very compact. Turn around. No, turn around. Trust me, yeah. You can see that it is reasonable. It's bigger than his back, but you have to realize that hiking backpacks are much larger. They go up to here. So this is more or less, yeah. Yes, you can. And then you can see on the other side, this represents the water that will be in the top container, and it'll flow through this tube right here, through the filter, and will fill up the bottom container. And these lines represent the partitions that will prevent the water from sloshing back and forth. Ladies and gentlemen, may I have your attention please? We at Team STC have prepared a little skit for you, so here's Michael to set the stage.
Diego Lodato, male, between the ages of 18 and 45, middle to upper class. Literally the perfect demographic and representation of a hiker. And he's just purchased the new state-of-the-art Koala Pack.
Wow, I just purchased a new state-of-the-art Koala Pack.
He is so surprised by the many features it has, such as a built-in filtration system, the ability to attach and detach to larger hiking backpacks, and its cool, sleek design.
Whoa.
Now we get to see Diego use his new backpack in the field.
Wow, I can't wait to use my new backpack in the field.
All right, so Diego is going to venture over now. He's going for a couple days on this hike. So he has to bring a lot of his other hiking gear, boots, tent, other stuff, and all that's rolled up in his big backpack. And now he's gonna take his Koala Pack and lash it on top. Now what's nice is that you would think, wow, you're adding this extra thing onto the outside. Wouldn't that add to the weight? You said you were trying to alleviate stress. Well, actually, because you would be carrying this amount of water in the backpack anyways, the Koala Pack really doesn't add a lot of weight. And actually, because you don't have to pack for several days' journey, just a few because you'll be able to replenish your water supply, it actually reduces your weight in the long run. So what Diego is doing now is he's taking the Velcro clamps and he's clamping them around the exoskeleton of the backpack so that he can be ready to go for his hiking. And Diego, I can only talk and embellish for so long.
Sorry, they called me.
All right. Diego gets started on his trail, and in just a few hours, notices how comfortable it is not to have to carry so much water because he can easily refill his pack wherever he finds water on the trail. But now Diego is setting up camp and doesn't want to carry his whole backpack with him just to refill his filter. Whatever will he do?
Thank you. I would take it out. And then fill it in, and then put it back in, and then put it on the back again.
The rest of Diego's trip continues in a similar fashion, with the Koala Pack providing spectacular functionality along every step of the way. It came in handy, saved his life twice, and ultimately resulted in Diego having the greatest hiking experience ever.
The end.
My team is going to be telling you the story of our relentless quest through the engineering design process. It's many frustrations, many long nights, but tonight, don't worry. To quote King Henry VIII, with regard to his many wives, I won't keep you very long. Here's Kevin to introduce our problem to you.
Okay, so the IT department here has a long-standing problem. They have hundreds and hundreds of desktop computers and video projectors, like the ones that are projecting the slides onto the screens. Now the thing is, over some weekends, the teachers are having fun at home grading papers, and then they go in on Monday and they try to turn on the morning announcements, and they find that the projectors will not come on. They will not respond to their remote controls. just a black screen, and that's it. And meanwhile, there are these desktop computers that they can't get on either. Although sometimes they will turn on, but they will make tons and tons of noise. It's that their fans will run at full speed when they have perfect ventilation. I mean, they're just on open desktops, yet, and they're not even being used heavily, yet they do that. Now the thing is, over the weekend, there have been, say, thunderstorms that have happened that have caused power glitches, such as brownouts and brief dropouts, and that can screw up the power supplies of the electronics. So our goal in this year's project was to design something that we could plug in between the electrical outlet on the wall and the projector or computer in order to deal with these problems without the IT department having to be there. Since the morning announcements are so early in the day that by the time they get there, it would be too late. We target school and corporate deployments because these are the sort of situations in which we have hundreds and hundreds of computers and projectors, and also other affected pieces of equipment like network switches and printers.
Thank you, Kevin. Okay, so as mentioned before in the previous presentations, here's a 12-step design process that we have drilled into our heads from freshman year. Freshmen, pay attention if you're in the audience. But keep in mind, engineering is primarily a way of thinking. That 12-step process is how you organize your thoughts as you're working at the project. The first semester, we spent our time primarily on the right side of the circle and defining our problem, figuring out what our approach is going to be, doing our market research and those types of things. And then when we come back from winter break, one of the few breaks that we actually get in engineering, we focus on the detailed design phase. Our project is much more narrowed down, and we focus on how do we implement our solution, and that's where we've been since January. All right, so this is our early research we did back in November, and we look at what products are out there already. Very important to know that in any engineering process where you're bringing a new product to market is, who is your competition? How can we be different? So and these are not the only products that are out there, but these are the 4 that most closely relate to our problem. That's the big black box, the big bulky thing is an uninterruptible power supply. That should look familiar to you. That is a standard power strip with surge protection built in. Household appliance module. And that product at the bottom there, we actually discovered that not in November, but we discovered that in April. It came as a surprise to us. It's a product that actually does almost exactly what we're trying to do. Now, to some of you glass half empty people, you might think that's a disappointment. But to engineers, we don't think that way. The glass isn't half full, it's not half empty, it's just too big. So like I said, the 12-step process, it's a way to organize our thoughts, but we don't necessarily have to go in that order. And I'll explain more about how our product works in the next slides. Another way to organize our thoughts is our decision matrices. In engineering, we're often dealing with very complicated, very difficult decisions. So how are we ever going to make one? Flip a coin? No. Call it a decision matrix. What we do is, once we establish our criteria and constraints, we take all of the possible options and rank them quantitatively. Whichever one gets the highest score, that's the option we go with. This is not the only decision matrix we used, but this is one that we used only a few months ago.
Now, much of the project is electrical based, as you find out soon, but there was a physical challenge that we had to overcome. Many power strips today are relatively small and don't provide the protection that the one we designed does. This is a model from our 3D printer. It does have 2 pieces that fit together. Now, the design that we added to it was we made it a bit bigger. And we made it bigger basically so it could fit the electrical components that it needed. We also added a humidity seal, so it did have extra protection in the high humidity environment that we live in. And here's Daniel to talk more about the electrical components.
Design. I also do want to mention that we've been experimenting with the 3D printer over the last week. It's been a lot of fun and very interesting. All of our models seem to come out either too big or too small. This model is actually bigger than the final product would be by about 2¼ inches, as we discovered this morning. This is the third attempt. Other teams have been having similar experiences with the 3D printer, so needless to say, it's a very interesting machine. Now, this is what our circuit does. We do have details about how it works up here on the board after all the presentations have concluded, but this is a very simple flow chart for you. Our circuit monitors the line voltage. It monitors the FP&L grid, basically. Deployments do have building level uninterruptible power supplies on them, so they wouldn't need a device like this. But many schools don't. That they're operating on tightly constrained budgets, a wide mix of a mismatch of equipment on the campus, and a large volume of it, often in the hundreds, depending on the size of the campus. We are using common components in the circuit, so it's nothing custom, nothing particularly unique, except the way we lay it out. I'd like to recognize Mrs. Rondon for her time and dedication to the class. She often comments on how I just never give her a break. Thank you all.
And could charge those iPads within the span of about a class period. We also had to make sure that the transport from classroom to classroom and across campus would be easy and that the library staff would have no problem maneuvering those carts. We also wanted to improve upon organization. This was a great emphasis for us. Consulted with Motorola electrical engineers. They basically told us that it can be done, but that we shouldn't do it. It would actually decrease charging efficiency. We also considered wireless charging and connecting all the chargers to USB hubs. We also considered customized adapters where the part that plugs into the iPad, we would actually make it removable so that if any damage comes to it from the kids, wearing, tearing them down during the class period, we'd be able to easily remove the compartment with all the electrical components. We also developed an idea where we would just have a cart frame and iPads would slide into individual pockets that would attach to that frame. It would require a lot less space and it would be easy to move around. We also considered a hand truck transportation option, which would allow for easier maintenance, easier transportation across campus.
And what are we going to make it out of? As you can see, our cart is actually mostly made out of wood, except for the few prefabricated pieces such as the handles, the wheels, the hinges in the back, which you can't see right now, and the straps holding it in.
This is our final prototype, and those are just 2 different shots of it.
The testing methods that we've started to use and that we'll use continuing forward are various stress tests. We want to make sure that the cart can actually hold the 30 iPads without any components breaking or bending. We also want to make sure that our weight distribution is in check, that it's not too top heavy, and that there will be no toppling when the librarians are trying to transport them across campus. We'll also be confirming the charging time, making sure that our configuration does in fact charge the iPads within the class period. And we'll also be letting the librarians take them out. The teachers also can test them out, make sure that they're easy to transport, and that they have no issues with them. Librarians will give us their feedbacks, and we'll go ahead and make whatever improvements we need to.
So, as you can see, our final product is right here, but we're still not finished. We have these future stuff you have to consider. We have to continue testing our prototype, letting the librarians test it and so forth. We have to refine the designs, some technical aspects, such as the handles. We're deciding, should we put a 3rd handle on it, or maybe allow the handles to pivot out so you can move it like a hand truck, as we mentioned earlier. Or actually the wheels, we can make bigger wheels, maybe pneumatic wheels, so it handles the outside terrain better. We have the ventilation problems. Currently we have some holes drilled in the back so as it charges, it heats up a bit, but the hole in the back prevents anything from overheating and catching on fire. Fire and wood is not a good combination. Some future ideas for ventilation could be, we could do more holes or attach 2 fans to it. One fan which blows the air in and another fan that sucks the air out. After we do all that, we're going to reevaluate it, make sure it still does what it was intended to do. And we would like to give it to American Heritage Upper School to test. We'd like to thank you for being able to sit through all 4 of these presentations. Nice use of your Wednesday night. But we'd also like to thank Ms. Rondon for helping us and supporting us throughout our entire project. And of course, as all the other groups I've mentioned, Monsignor Salafia, without him, this wouldn't exist.
Bravo.